All right, let's dig in. Today, we're going deep, and I mean literally, to uncover the hidden science that makes your soil, well, soil. It's this incredible story of microscopic chemistry that decides whether your plants are going to thrive or just survive. So yeah, let's get our hands dirty and see what's really going on down there.
So, have you ever really stopped to think about it? What is it that actually gives soil its power to grow life? I mean, we call it dirt, but it's so much more than that. It's a living, breathing system with this hidden power source. And no, it's not magic, it's some seriously cool chemistry and physics, all happening on a scale you can't even see.
You know, the best way to wrap your head around this is to think of your soil as a rechargeable battery for your plants. It's literally storing and delivering all the essential energy they need. And the secret to this whole battery, the thing that makes it work, it all comes down to the tiniest little particles, clay and organic matter.
Okay, so to understand how this soil battery works, we gotta pop the hood and look at the parts inside. And for that, we need to zoom in, way in, down on the microscopic level of clay minerals. They're like the layers inside our battery, and they're built using a really simple recipe that I like to call the clay sandwich.
Believe it or not, it all starts with these two simple geometric shapes. You've got the tetrahedron, that's a silicon atom hanging out with 4 oxygen atoms, and then you have the octahedron, which is usually aluminum or magnesium, surrounded by 6 oxygen or hydroxyl groups. These two shapes, they're basically the bread and the filling of our clay sandwich.
So, you take these building blocks, and they start stacking up into these thin sheets. A simple one-to-one structure is like an open-faced sandwich, one tetrahedral sheet on top of one octahedral sheet. But a 2-to-1 structure is a classic sandwich, with that octahedral sheet tucked right in between 2 tetrahedral sheets. And this stacking pattern, it's what gives different clays all their unique personalities.
But wait a second, how does a layered sandwich become a battery? Well, the secret isn't in the structure itself, but in a tiny little mistake. You could call it a perfect imperfection that happens while these minerals are forming over thousands of years. This right here is where the real magic happens. This secret has a pretty long name, isomorphous substitution. I know, it's a mouthful, but the concept is actually simple. It's like a tiny typo in the recipe. As the clay is forming, sometimes an atom gets swapped out for another one that's a similar size, but, and this is the key part, has a different electrical charge. Think of an aluminum ion sneaking in where a silicon ion is supposed to be.
And here's where it all clicks. An aluminum ion has a +3 charge, but the silicon it replaced had a +4 charge. So that little swap leaves behind an extra electron that doesn't have a partner, and that gives the entire clay particle a net negative electrical charge. It's a tiny imbalance, but it has huge consequences.
So why do we care so much about a negative charge? Because it turns that clay particle into a magnet, a nutrient magnet to be exact. It attracts and holds on tight to all these positively charged ions, which are called cations. And what are cations? Oh, just the most important nutrients plants need to live, things like calcium, magnesium, and potassium. Without that negative charge, all this good stuff would just wash away with the next rainstorm.
Okay, this is cool. So soil particles have this magnetic pull that holds onto all the good stuff for plants. But how do we measure that? How do we know if a soil has a really strong magnetic pull or just a weak one? Well, soil scientists have a way to put a number on it. It's called Cation Exchange Capacity, or CEC for short. Just think of it as the power rating for your soil's battery. It's a measure of the total number of those negative charges that are ready and waiting to grab onto nutrients. The higher the CEC, the more nutrients your soil can hold. It's really that simple, a bigger battery.
So how do they actually measure this stuff in a lab? This flowchart gives you a little peek behind the curtain. Basically, scientists give the soil a thorough washing to knock off all the nutrients it's currently holding. Then, they see how many new nutrients it can grab and hold on to. It's a super precise way to figure out the soil's total battery capacity.
Look, I know this all sounds pretty scientific and maybe a little abstract, but understanding CEC has absolutely massive real-world implications. This is where we connect the dots between the lab and what's actually happening in your backyard, on a farm, or out in the environment.
Your soil's texture makes a huge difference. Just look at this. Coarse sandy soils have a really low CEC, a weak magnetic pull. But as you move down the list to finer soils, like clays, and especially soils packed with organic matter, whoa, the numbers shoot way up. Their ability to hold on to nutrients is just incredible.
So what does this mean for you, practically speaking? Well, a low CEC sandy soil is kind of like a leaky sieve. Nutrients and water just pour right through it.
You have to feed it and water it in little sips all the time. But a high CEC soil, like one with lots of clay or organic matter, that's a nutrient reservoir. It can store a ton of nutrients in water, releasing them to plants whenever they need it. It's just so much more efficient.
And that brings us right back to the beginning, to the big question. Now that you know about this hidden electrical charge that powers the ground beneath our feet, you can ask yourself, is my soil a powerful nutrient magnet, or is it a leaky sieve? Because knowing the answer to that is the very first step to unlocking its true potential.